In this video, I will talk about running Kubernetes on cloud and benefits of a managed Kubernetes services. We will talk about spinning up a cluster, load balancing, data persistence in Kubernetes cluster, and the problem of moving or migrating from one cloud platform to another. There are so many tools and trends like infrastructure as a service, Kubernetes on cloud, managed Kubernetes service, etc. These services have over the past few years and are trending now. So it's good to get a good big picture overview of all this, and that's what I will cover in this video. One of the known infrastructure as a service platform is Linode. Let's use it. So let's build a case where you and your team are developing a microservice application with a database that will be deployed in Kubernetes cluster. You want your application to be available from a browser. It's your domain name with secure HTTPS connection. Plus you have some requirements like security for your whole cluster setup, of course, and the data persistence for your database. And because you wanted to do it properly, you wanted to have developments and production environments that are the same. So you can properly test new features before releasing them. So this is your setup, and you wanted to get this as efficiently as possible without wasting a lot of time and without having to spend your whole time learning and figuring out every piece of technology. So bear that setup in mind while we go through the following concepts. Okay, and by the way, this whole setup that I will explain in this video with concepts, I will make a practical demo of it so you know theoretically how all this works but can also implement it in practice. So basically you have a complete knowledge for this specific scenario from just 2 videos. So let's dive right in. First of all, where will your Kubernetes cluster for application be deployed? Consider you wanted to set up Kubernetes cluster on a cloud platform like Linode. How does this actually work? Now there are 2 options to do that. Option number 1 is you can spin up, let's say, 6 Linode servers instances and create your own Kubernetes cluster from scratch. Meaning you install master processes on 3 nodes and make them master nodes. Then install the worker processes like kubectl, kubeproxy and a container runtime like Docker on the other 3 and make them into worker nodes. And once you have set them up, you have a cluster, and now you can deploy your applications on it. So the whole cluster, master and worker nodes are your responsibility to manage, secure, do backups, etc. So you have to manage the cluster yourself. It is doable, but it's a pretty big overhead to install all these binaries and processes and to put the cluster together. If you just wanted to create a simple cluster to deploy your applications, the option of creating cluster from scratch on cloud instances is not very practical because, as I mentioned, you wanted to get things done fast and easy, and don't want to spend too much time on setting things up and figuring it all out. So as an alternative, cloud providers like Linode also offer what is called a managed Kubernetes services that does a lot of heavy lifting for you. On Linode, it's called a Linode Kubernetes engine. So how does this work? Or what does it actually represent? So you don't have to create cluster from scratch. Most of it is done for you automatically by Lenovo platform. So when you create a Kubernetes cluster on LKE Linux engine, you just choose how many worker nodes you want. So you just care about worker nodes. You will get, for example, 3 worker nodes with all the processes including Docker container runtime pre-installed. So you don't have to install any of this and you will get them up and running in no time. So what about the master nodes? Who creates them? Who manages them? Where are they? The thing is, Linode creates the master nodes, are also called the control plane, in the background when you create the cluster. But you don't even see that because it's completely managed by Linode. It's not your responsibility anymore. So you don't have to manage, secure and do all the configurations on it. That's one advantage. But this also means that you only pay for the worker nodes. Now you don't pay for this extra couple of nodes that run as your master nodes. It eliminates not only extra costs but also a lot of effort and overhead because you can literally just get started in minutes with the running Kubernetes cluster. So it saves a lot of time. So let's go through this in more detail. How does this all work? And what can you do with the Linode Kubernetes engine? The process is pretty simple. Let's say you create a cluster with 3 worker nodes to deploy your application on Linode UI. Choose your worker nodes with their resources. Linode has server instances of different capacities, so depending on your needs, whether it's a test, development or production environment, you will choose which nodes you need with how much capacity. Then you select a region or data center where the worker nodes will run. So for example, if you are, let's say, in UK, maybe you create cluster in your nearest region in the UK, and with a couple of clicks your Kubernetes cluster will be up and running. Then you connect to the cluster using kubectl from your laptop and deploy your application services and do all these things that you need to do in the cluster. Super straightforward. So let's say you need to deploy a MongoDB database for your Node.js application and you want several replicas of that. Now database applications need data persistence, right? To save that application data. And if you have 3 replicas of a database, you need persistence or storage for all 3 replicas. If you wanted to learn generally how data persistence work in Kubernetes, I have a separate video about that, so you can check that out now if you haven't watched it already. You know, there are different type of storages, like there are cloud storage providers, there is NFS, local storage and the nodes themselves, etc. And the storage you have to configure yourself. Kubernetes doesn't do that for you. So you would have to create the storage, the physical actual storage, and make it available for the cluster resources like database. Then you would have to create persistent volume components with the storage backend. And now you can attach these volumes to your database parts. Well, Linode has its own storage, Linode block storage, that you can use to dynamically create the volumes. So you don't have to set up and configure anything. You don't have to create the physical storage and then create volumes out of it and connect them, etc. You just use Linode's storage class and Linode will create the persistent volumes with the respective physical storage in the background automatically. And when you deploy your database application, the storage will get attached to your database pods, and you will see all this in a demo part in detail. So you have a very little effort here as well. Of course, it's good to know how it works, but you don't have to do much here. Okay, so now you have your Node.js application running as well as MongoDB database application with replicas and its storage configured. So now we need services and access from the browser through Ingress, which is part of Kubernetes, that basically manages routing of incoming requests like from a browser to internal services in Kubernetes. So in our example, you would need to install and run Ingress controller in your Kubernetes cluster so that you can configure Ingress rules that will then route the incoming traffic to your Node.js application. To understand the concept behind this, in a cloud environment like managed Kubernetes service or in a Linode Kubernetes engine, how does this setup work? How will Ingress get that incoming request? It happens through Linode's load balancer. So in cloud platforms, you have cloud providers' own load balancer implementation that gets in front of the Nginx Ingress controller. So that becomes the entry point of your cluster. So let's see how that works. Linode load balancer is, as the name says, a load balancer for your worker nodes, where nodes are the Linode server instances. So say you have 2 Linux instances, one runs as a database application and other runs as a web server. And you expose the web server using a public IP address so that browser can send requests directly to the web server. The problem is you can't scale this application if you suddenly start getting a lot of traffic. Your web server will become a bottleneck. Also, if you make changes to the web server like reboot it, reconfigure it, etc., your application becomes unavailable. Instead, let's say you add a load balancing front that takes the incoming request and directs it to the web server. So load balancer will get the public IP address and web server will be hidden away and accessible only at private IP from the load balancer itself. Now you can add multiple web servers under that load balancer. That load balancer can forward the request. So you can scale your application up and down without users even noticing anything. Now you have an entry point to your application that you set up once and just leave it. And it works. It's just there to accept the request and then redirect it to one of the web servers. You can also configure session stickiness with Linode's load balancer, which means if user authenticated on one server, that keeps sessions in the memory, meaning only that web server instances has the session information and knows the client. You can configure the load balancer to forward the next request from that client to the same web server instead of randomly picking or passing the request to any server. So the same client will always land on the same backend. And trust me, if your application keeps session in memory, this will be the first thing you are gonna be asking how to solve. So this feature is very helpful. Now obviously you need your connections to be secured. So you can also configure the load balancer with the SSL certificate pretty easily. You can do that using a plugin called Set Manager, which basically helps with managing SSL, TLS certificates. Remember, we don't want to spend time doing everything ourselves. We wanted to delegate most of this stuff to technologies. So in this case, you can get the certificate and store it as a Kubernetes secret and use it to secure the connection to your cluster. Now as I said, I will make a demo video right after this where I will show you all of this in practice. Click the notification bell after subscribing and you will get notified when new video is out. And as I said, the concept you will learn on Linode, you can apply on other platforms as well. So far, I have used 3 or 4 different cloud platforms and the usage concepts are pretty similar. It's just that some platforms are better in doing certain things. Now that you have a successful setup, your application is scaled and available through browser, users can use it. And let's say when you created your cluster on LKE, you selected a region, let's say Dallas, USA. So that's where your cluster or work nodes are running. Suddenly you notice most of your users are accessing your application from Europe and India. Let's say this means that connection speed is not good for users because the servers are located geographically too far away from them. So you wanted to host your application in closer proximity to your users. That's where the availability zones of a cloud provider come into play. Linode has data centers in 11 physical locations, also called availability zones, where you can run your nodes. So if you wanted to roll out your application for German and Indian users, for example, you can simply select the data center locations near them. Now let's say everything is set up on LKE, your application is running, you have it in multiple data centers, all look good. Your team or company decides, you know what, we would like to move our data and all the sensitive information from the cloud platform to our private cloud. And also there is this new feature of our application that will be most effectively done using a specific service in cloud platform, be whatever that is. So basically you wanted to migrate part of your application setup to private cloud and part or just one feature to another cloud. Usually what happens is when you set up your Kubernetes cluster on a cloud platform, you end up using its services like native load balancer and storage or some APIs that are specific to that cloud provider. And you can't migrate easily. You may need a lot of reprogramming and reconfiguration to move part of your code or the whole application away from the platform and migrate it to some other place. That's called vendor lock. And an obvious reason for that is, of course, cloud platforms wanted to keep the companies tied to them by providing these useful super services, but which are cloud specific. So you can't move your application easily afterwards in case you need it. Linode, however, doesn't have that vendor lock-in, which is a great thing. If you come to the point where you actually need that migration or partial migration, so you would be able to easily do that above and move your workloads to other platforms. And they do that by being open cloud and having their API completely open and free. So they don't lock you in with their native API. Another point is, let's say your setup grows in size, you deploy more and more services, your infrastructure configuration gets more complex and your DevOps teams grows as well. In this case, you would want to automate as much as possible. So you may automate creating, configuring, tearing down, doing all sort of things with your infrastructure where your cluster is running, and also automate deploying your application and services. And you can do that using automation tools. So for Linode specifically, you can use these tools to automate your infrastructure and also deployment of services in that infrastructure. So for example, tools like Terraform or Ansible, which are automation tools, have modules or providers or whatever they called in their respective tool that can connect to Linode platform to get access to its resources and then let you automate your DevOps work to again save time and work more efficiently. And finally, a couple of things that must be mentioned about Linode Kubernetes engine that may seem minor at the beginning but can also be very important. First one is creating a cluster initially or many cloud platforms usually takes long because the master nodes need to be provisioned, the configuration you selected must be applied, some other resources must be created, etc. So on some platforms it could be up to 20-30 minutes even to just initialize the cluster. On LKE, when you create a cluster, it takes under 5 minutes, which is way less compared to other platforms. And it's pretty fascinating when considering how much actually needs to be done in the background. Now you may think that you only need to create cluster once and that's it. So not a big deal if I have to wait half an hour at the beginning. However, when you are just starting off, you wanted to practice, you wanted to test or maybe create test or trial cluster, you may need to do it a couple of times, especially at the beginning. For example, I create demos and try out some new things on LKE, so I need to create and tear down the cluster pretty often. So in this case, it can save a lot of time. And finally, another detail that I notice in that, you can SSH into your worker nodes, which can be very useful when troubleshooting, for example. And surprisingly, this is not a common thing with managed Kubernetes service because the other two cloud platforms that I have used, they didn't support that feature, or more correctly, they didn't allow that feature. So you can actually SSH into your nodes, into your worker nodes, in case you need to troubleshoot something from that. But know that you have to be careful when using the SSH into Linux nodes because you can easily break something or the server. So unless you know exactly what you are doing, avoid changing some stuff there. So that's it for the introduction of managed Kubernetes service with an example of Linode Kubernetes engine. Thank you for watching and see you in the next video.